This screencast is designed to give you a quick overview of Module 6, Lesson 3, which is about equations in standard form. You've actually already seen standard form because we've mentioned it before now, but we're just kind of officially going through it, and we're going to add it to our arsenal, our set of tools for linear equations. Okay, so you've already seen the standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. Okay? You can write equivalent equations in slope-intercept form and point-slope form. Okay, so basically what they're saying is you can have one line and you can write that line in 3 different formats. You can write that linear equation in standard form, you can write that linear equation in slope-intercept form, or you can write that equation in point-slope form. Okay? They all have their advantages and disadvantages and their uses. And if you know one, and you know what you're doing, you can convert it to either of the other two. Okay? All right. So it says use the 3 forms of the equation shown to complete each step. All right, well, first of all, circle true or false. You can read the slope from the equation. Well, in standard form, that's kind of difficult to do because of the format that it's in. But in both slope-intercept and point-slope form, the slope is very obvious. And in this case, it's the 2/3, negative 2/3. Okay? It's stated right there, it's stated right there. In standard form, you'd have to solve for it. All right. C, circle true or false. You can read the y-intercept from the equation. Again, in standard form, no. Slope-intercept form, yes, because it's literally called slope-intercept form for a reason, because it gives you the slope and the y-intercept very obviously. Point-slope form, you cannot directly see what the y-intercept is. Obviously, you can find it, but it's not given to you, plain and simple, just for you to glance at. Okay? In this particular situation up here, the y-intercept is -4. That's obvious in the slope-intercept form, but it's not as obvious in the other 2 formats. Okay? All right, so go down and look at number 1 and 2 on the reflect. Explain how you can find both intercepts using the standard form. Okay, in ax plus by equals c, remember to find your x-intercept, you're going to replace y with 0. To find your y-intercept, you're replacing x with 0. We've already done this. We did that back in Module 5. Okay, and so standard form is kind of helpful if that's something we want to do. How can you find a point on the line using the slope-intercept form? Well, you already know a point based on the equation because the y-intercept is stated. B is your y-intercept, and so you know one point. That's 0, comma, b. Okay? All right, go to page 274. Creating linear equations in standard form given slope and a point. So these methods are when you are given slope and you're given one point and you're asked to write them eventually in standard form. Okay? So you've got a slope and a point. You can use point-slope form, simplify and rewrite. You can use slope-intercept form, simplify, and rewrite. Okay? Here's another example down here. Again, you're given slope and one point. Put it in point-slope form or put it in slope-intercept form. And then once you have, basically, honestly, on your point-slope form, you're going to generate slope-intercept, and then from slope-intercept you can go to standard. Slope-intercept form obviously is a little bit more direct path, I guess. But again, you have to take the slope-intercept and convert it to standard form. But you can go back and forth between different types of equations. Okay, they all represent the same situation. It's just they're writing it in 3 different ways. So this on page 273 is going to be very, very helpful. And then the examples following just kind of give you some ways in which to make your conversions. Okay, how about creating linear equations in standard form if you're given 2 points? Okay, so you're given 2 points. You have to derive the slope from those 2 points, then substitute the slope and either of the given points into point-slope form, or you can find the slope, substitute coordinates of either given points in point-slope form for this one. Okay. Eventually you get to slope-intercept, and then you can keep going and put it into standard form. Okay, again, over here also, you start with point-slope form because you've gotten the slope and you've got to use one of your points. You can get it to, honestly, that's not actually slope-intercept form because you'd have to move the 4, but you could go from slope-intercept form. Anyhow, the bottom line is take it, rewrite it in standard form, which is just ax plus by equals c. So in this case, you would just have to move the y over here. Okay? And then what they did is they got rid of the fraction by multiplying everything by 2 so that they have whole numbers instead of fractions. Okay? Okay, so here's an example. Notice I scratched out number 7, so all of this writing in red has to do with number 8. It's just I was running out of room, so I just scratched out and used some extra space over here. So you start off with 2 points, and you need to find your slope, and then once you find your slope, you can put your slope and one of the points into point-slope form. And then you can do the math, you wind up with slope-intercept form, and then you can move the x over here so that you have it in standard form, because remember, standard form is ax plus by equals c. Okay? And I'll accept it either this way or this way. This one has the x as negative, this one has the x as positive, but mathematically they're equivalent. Okay? Okay, a few more examples on page 277, and then we're going to call it good for lesson 3 and move into some practice. So number 9 says that your school sells adult and student tickets to a school play. Adult tickets cost $15 and student tickets cost $4. The total value of all the tickets sold is $7,000. How could you write an equation in standard form to describe the linear situation? Well, standard form actually is really pretty useful in this case because you've got $15 for every adult ticket, and I guess we're going to go with X being adult tickets, and $4 for every student ticket, and so I guess we're going to use Y for students. So 15 times X, that's your cost for adult tickets, plus 4 times Y, which is your total cost for your student tickets, and that is the total amount that they made from the tickets. Okay, so you could write it this way. If you decided that X was going to represent student tickets, then you would write it this way, and Y would represent adult tickets. So it doesn't make any difference. It didn't tell you which one had to be X and which one had to be Y. Just be careful and be consistent. Okay. And then number 10. You're asked to write an equation in standard form to model the linear situation. So number 10, again, I'm using the space over here without actually answering number 11. A tank is being filled with gasoline at a rate of 4.5 gallons per minute. The tank contained 1.5 gallons of gasoline before filling started. So 1.5 gallons before anything started would be like your y-intercept. What do you have before anything happens? And then the rate is 4.5 gallons per every minute. So X represents the number of minutes. And then I can subtract 4.5x and put it over here, and I get ax plus by equals c. Or if I want my x as a positive, basically take everything and divide it by -1, and you wind up with this. Either one is equivalent, okay? But ax plus by equals c.